So again, for every SDET or QA that has some technical chops, this is how you can get back at them. Right? This run some test mutation and expose them.
Hit it.
Welcome to the TestTalks podcast, the place to go to geek out on software testing. And now your host, whose mission is to help you succeed with test automation, Joe Colantonio.
Hey, welcome to another episode of TestTalks, a podcast dedicated to all things test automation related. I'm your host, Joe from joecolantonio.com. Today we're going to be speaking with Scott Nimrod all about software craftsmanship and how to take your development and testing efforts to a whole nother level. Scott's enthusiasm for quality and development really shines through in this episode, and I think it's contagious, so you definitely want to check it out. But first, let's hear it for our awesome sponsor, Sauce Labs. TestTalks is sponsored by the fantastic folks at Sauce Labs, the cloud-based automated testing platform that eliminates the need to maintain your own Selenium grid and test infrastructure. Try it for free today. Visit testtalks.com and click on the Sign Up Now link under the homepage sponsor section. Hey Scott, welcome to TestTalks.
Hey Joe, thanks a lot.
It's great to have you on the show today. Before we get into it, could you just tell us a little bit more about yourself?
My name is Scott Nimrod, born and raised on the mean streets of Cleveland, right? And I started my career in software testing. And after I graduated, I transitioned from a co-op working in software testing to an application developer. But I've never, ever ignored my itch to basically leverage QA controls. And so it's something that I hold very dear to my bosom. And it's something that I just wish other developers can appreciate just as much as I appreciate, which I'm trying really hard to change the mindset, but it's a campaign, a personal campaign that I'm on. So in regards to languages, start off with C++, then VB, then the C#, and now I'm really excited about F#. And it's showing a whole new world of possibilities, not just for cranking out applications, but also it opened up some other techniques that I just wasn't aware of in regards to test automation. I guess perhaps I can provide some insight on my world of the perspective from the developer, the application developer, as it relates to test automation and some of the battles that perhaps SDETs and other members that participate in QA have to go through when they work with people like myself. Maybe we'll touch on that, but hey, that's why I'm here. I'm trying to provide as much of my personal experience as possible and also share what I've learned so far.
So as a developer, how did you get into test automation? Most developers I know, when they hear the word testing, their eyes glaze over and they just completely tune me out.
Yeah, you know what? That's a shame too. That's very unfortunate. But I got my associate's degree in mainframe programming. I started off my career towards maybe in the middle, or no, I graduated high school during Y2K, but I really didn't know what that was. But I'm answering your question. It's just taking me a little while to get there.
Yep.
I ended up going to community college, and I ended up doing mainframe programming, and realized that there wasn't an abundance of jobs out there for people to write COBOL. And so someone made me the offer to work as a co-op, in which I would go to school and also put in 20 to 30 hours a week within their QA department, or really they called it software testing department, in which I would write automated test scripts using Visual Basic 6.0 and in a combination with XML to data drive those tests. So that's how I got introduced to test automation. But as like a 23-year-old that just wrapped up with community college, and I get my foot in the door at a software company, and I see this lab that they have of like maybe 6 different machines that's running from Windows NT to Windows Server 2000 to Windows XP, And I'm in this lab, and someone is like showing me different parts of the company's, I don't know, floor plan or whatever. They're giving me a tour, and I see these computers that are like running these applications, but there's nobody like sitting in front of the computer. So I look at it and I'm like, oh, it's like ghosts are like, interacting with the software. Like, how did y'all do that? And they're like, oh, that's our test automation. And I'm watching like, menu controls, come down, and menu selections and page navigation. I'm like, yo, I never saw that before. Like, man, am I going to be doing that? And they're like, yeah, you are. That's why we hired you. You better be doing that. And I'm like, okay. So that's how I got introduced to it. And I immediately like, I didn't know exactly what I was looking at, but I knew it was cool. And that was my step into test automation.
Awesome. So as you transition more into development, do you still do test automation, or what kind of testing do you still include in your life cycle?
Yeah. So I'm all about RGR, okay? Red, green, refactor. And that's a, I don't know, acronym, if I could say that, for performing test-driven design or development. And so before that, I would crank out an application, but in order to test my application, I would have to launch the application every single time, which is time consuming. And it's really time consuming when you're working within a mobile environment. Once I learned about test-driven development, and I started like researching it, and most of the hits were coming from Uncle Bob. Right? I often say I'm a disciple of Robert Martin's teachings. It started resonating with me, and I felt like I was focused. I felt like I was on a roller coaster, and I was safe because I'm hugging the rails, and I'm not going to venture off the tracks because I'm locked in, and it just keeps me like just focused. I feel like, I never shot a gun before, but if I had a Uzi or like an AK, there's tracer bullets. I know where I'm going. I know the destination that I'm trying to get to. And that's the way I feel about test-driven development or test-driven design. Red, green, refactor, red, green, refactor, red, green, refactor. That's the flow. It's so I guess it's the flow that I appreciate, that I'm addicted to. And ever since I've learned that methodology of building systems, I get frustrated when as a contractor / consultant, I go into other shops in which, yes, in 2015, the majority of developers, I guess I can't relate to Wall Street or Silicon Valley, but the majority of shops that I've been at, even in 2015, as we approach 2016, they're still professional debuggerers. Okay, they are still, in order to prove that their code works, they still feel as if they have to launch the entire application, spend several more seconds, if not minutes, putting the application into a specific state to step through the debugger and validate that their code works as expected or intended. And the frustration is a lot of these companies, they fight change, even though it should really be common sense. So in a way, I feel like a lot of these companies that I'm trying to help, they're fighting common sense of what professionals should be doing. And it's kind of strange that, and remember, like I'm speaking as an application developer that came from a test automation background. And so it's weird how a lot of these shops, they view QA as kind of like a savior to what they're doing, because all they need to do is crank out code and then say that they did it. And I think most developers, and this is me speaking, I don't think they really think about cranking out code that's proven and then say, here, QA, I want you to use your amazing brain and flush out bugs that really requires creativity to flesh out. I think a lot of us, we just write code and whatever is on the acceptance criteria, which is I think is usually happy path scenarios.
Yep.
We say check, check, check. All right, QA. And we expect QA to pretty much tell us what else we need to do when a lot of things we could be finding out on our own by just doing very just straightforward SAT path scenarios.
Awesome. And you bring up a lot of points here, Scott. One thing that's kind of funny is I was in a code review the other day with some bugs that made it into production, and we're just reviewing why it happened. And the developer said, well, these tests were running flaky. The functional tests were running flaky in the CI environment, so we kind of ignored it. And when we found out what the issue was, it was just that they weren't checking that an object array was being returned, which someone brought up then, shouldn't that be a unit test? And the guy said, yeah, I guess it should have been a unit test. So it's funny, if the developers just did a quick unit test, like you said, that's fast and doesn't rely on standing up the whole application and running in continuous integration every night, they would find it. So how do we get to that point? How do we move a developer from what you call them a professional debugger to a professional software developer? Is it even possible? If someone just doesn't have that drive, like it sounds like you do, how do you get someone there?
Yeah, so consider me a software craftsman militant, okay? Because my views are pretty extreme compared to the people that I work with. But I think this is the first step, okay? I'm not going to hand out doctrine, but I'm going to tell you what I think is a first step, and this is the way that I operate. This is the standard that I hold myself to. Okay. Are you ready, Joe?
Yeah, lay it on me.
All right. I have reason to believe that within the agile movement, which agile comes in a spray can. We spray it on ourselves, and we say that because we do daily stand up, we're agile,
yep,
right?
Yep.
But I have reason to believe that within the agile movement, it's popular belief that the development team is responsible for the quality of the code. Okay, that's the belief system that I've come across.
Yep.
Now, I think that system is flawed when it comes to DMDs, dark matter developers, and this is something that Scott Hanselman had wrote a blog post about. Developers that they're there to collect a check and do a good day's work, but they're not really obsessed about software.
Yep.
They don't love building, molding, and delivering software. When you say that everybody owns the code and everybody's responsible for the quality of the code, I have reason to believe that results in no one taking ownership of the code. It has like opposite effects. Now, this doesn't really apply towards your top leading organizations, right? I don't think when you have people that are just gung-ho about building incredible software, or translated, when you have a team of software craftsmen, then I don't think you have to worry about that, because they take great pleasure in delivering and working and building what they build. But I think when you take developers that aren't as excited, and you take developers that the only thing they know about software is what their company has taught them, and they're not necessarily a servant of the industry. No, they're a servant of their company's practices, regardless of its effectiveness. When you have that type of environment, then what happens is your agile team, they don't own the quality of the code. And what happens is after several months or a year or two, it becomes harder and harder to build sustainable / extensible features on top of your code base.
Awesome. So, Scott, are there any books or resources that you would recommend to someone to help them learn more about how to be a better software craftsman?
Yes, but they have to want to be a software craftsman. It's so one book is X Unit Test Patterns. That changed the way that I write code. It's X Unit Test Patterns. It's a healthy book. It's probably about 500 pages, and it talks about code smells, and it's pretty much design patterns in regards to the ecosystem of test automation, of unit testing specifically. And so that book is a Bible, right? And I consumed that book like 5 years ago, or 3 or 4 years ago. And just last month, I decided to just go through that book one more time, just to refresh my thoughts, so that when I'm cranking out code, I can still reference certain ideas and then go back to the book to research it, right? So X Unit Test Patterns is one book that I think is very, very vital, for people to be mature when it comes to proving that their code works. Because here's the thing, Joe. I think the majority of developers, I think they think that they write unit tests, okay? And I think when developers think that they write unit tests, I think that belief is somewhat flawed, because I don't think unit tests are written. I think unit tests are engineered. And this is what happens, where developers they'll try to spray on their agile. They'll take their agile can and spray it on. They'll be like, all right, fine, TDD. And they'll start writing out a lot of useless tests.
Yep.
And then as the code base matures, they spend more time trying to maintain their tests, and then they give up on test automation, or they give up on test-driven development. Why? Because they decided to use the company's time and practice on company hours to make their mistakes, instead of being software developers, being professionals, and realizing that it's their job to stay up to date. And just like a boxer, boxers don't. I don't know that much about boxing, but I don't think boxers get paid to train outside of the ring. I think they get that purse when they perform, or after they perform inside the ring. And I think developers, they're missing that. They have this expectation that that we only practice on the clock, and it's okay to make mistakes on the clock, because we don't want to make mistakes on our own time. And so, I guess, to make a long story short, I think that our heart has to be into it.
Yep.
Our heart has to be into unit testing. Our heart has to be into test automation. And then they'll learn about when instead of writing unit tests, they're engineering unit tests. They're building a test API, to support whatever mocking or subbing that they need for their test method clients. And they'll start. I also wrote a blog post that I referenced from unit testing in F#. That's a book. I probably butchered the name of the book, but it's like F# unit testing. And in that book, they speak of the 10 commandments of unit testing. I can't recite them all, but it's something that I think a lot of developers should at least, look up and just evaluate if those 10 commandments really make sense or not. I think they do. In addition to that, for SDETs, if SDETs really want to expose the quality of unit tests out there, then I highly recommend that they at least research test mutation. Joe, are you familiar with test mutation? Because I didn't learn about it until like 2 weeks ago.
No, but what's test mutation?
Okay. And again, when I started studying functional programming, because I feel like as application developers, we use object-oriented design as a sledgehammer to solve all problems.
Yep.
And this functional programming is opening up a world to me, not just for programming, but for also testing, right? And so test mutation is essentially this. Test automation, as I understand it, and I'm not an expert, I'm not the authority, right? But as I understand test mutation, it's you write tests or you execute tests that test tests. Okay, so you're testing your unit tests. So what happens is this. My understanding is in .NET, there's a couple test mutation frameworks such as Ninja Turtles. Hence, Ninja Turtles are mutants, right? And there's also a visual mutator. Java has several of them. The Java stack or the Java ecosystem. But basically, what happens in test mutation, as I understand it, again, I'm not an authority on it, is you run a tool in which you point the tool to your unit tests, and this tool will basically take the system under test or the target of your unit test, and it will flip or swap operators within the function or the method that's involved or that's the target of your unit test. So for example, if you're unit testing a method that has some AND operators, your test mutation will take that DLL or take that code, the function or method that's being tested, and it'll swap out that AND operator for OR. Or it'll swap out the AND operator for, it'll put a negation on it. Same thing with plus operators, minus operators. It'll take a plus operators and swap it out with minus. So what happens is this. The product or the benefit is you can run this tool and you can get a better understanding of what unit test developers wrote. They're BS. They just did it for code coverage constraints, right? So if I'm all about code coverage, right? And a lot of people say, Scott, that's stupid because developers would just do whatever they needed to do, regardless of the validity of that test, just to meet code coverage requirements. And I'm like, okay, fair. You're absolutely right. When you have developers that don't have their heart in equality,
Yep.
But in SDET or another developer that's a craftsman that is really sick and tired of this culture of application developers not really being concerned with quality. They believe that quality is the job of QA. Then, as payback, as revenge, and I wrote a blog called "Revenge of the SDET," is they can leverage these test mutation frameworks and they can run it on the developer's unit tests and flag all the unit tests that pass regardless of the operators that are being used within their tests. Again, the logical operators, and, or, plus, minus, multiply, etc. And if those tests still pass, then your test mutation test will fail those unit tests. And so it's a way to, again, evaluate. It's a tool for evaluating or examining the true quality of your tests. We're not even talking about code anymore. We're not even talking about the deliverable of the application. We're now scrutinizing, are the tests really tests? Or are they just fudge that developers are just trying to just throw just to satisfy management's concerns or management's constraints or gated check-in constraints? So again, for every SDET or QA that has some technical chops, this is how you can get back at them, right? This run some test mutation and expose them. And that might sound really political, but at the end of the day, I think the reason why we're building software is for the client. And not only that, I really want to build software that is cheap and also has high quality. And I believe that both can exist. I believe that you can reduce the cost of software if you just have the proper checks and balances that every other industry has, except for us. So the more tools that we can leverage, if the developers aren't leveraging these tools, then I think as QA and as SDETs that work in the same house as QA, we owe it to ourselves to use these tools. And I would never have ever found out about test mutations if I weren't studying F#. And then there's another one that developers can use as well. And this is called, Joe, have you heard of property-based testing?
No, you really laying some new ones on me that I know.
Again, if I never studied functional programming, I would continue my ignorance, right?
Yeah.
So property-based testing is this. Unit tests are really example-based testing, okay? So what does that mean? As a developer, you are writing a test that is very specific to a case scenario. You're saying with this specific value or with these specific inputs as my setup, I'm going to exercise this method, right, or this behavior, and I expect this specific output, okay? Property-based testing is this. Are you ready?
Yeah.
Okay. Instead of putting in specific inputs and asserting specific outputs, we're testing the properties or the characteristics of a function. Now, what does that mean? Okay. Again, I'm not an expert on this. I've only been aware of this for like 2 weeks. But my understanding of property-based testing is you're testing the behavior of a function, the properties, the characteristics of a function. So we know that if we have a function called add, then there's certain principles that this add function has. If we add two numbers, if we execute an add function and we provide two inputs for adding, like a variable that points to 1 and another variable that points to 3, we know that the principle of, or a property of that function is the result of that function when adding two numbers should never be less than the product of those two numbers. If I provide inputs 1 and 3 into an add function, then the result of that add function in regards to the absolute values of those inputs should never be lower than the product of those two inputs. So I should not have a result. If 1 plus 3 is 4, I should never have a result that's less than 4. That is a characteristic of that function based on absolute values. Another behavior of a function is if I provide inputs 1 and 3 for an add function, I should get the same output as if I swapped the inputs. So if I first put in for the add function 1 and 3, and it equals 4, right? If I swap the inputs and instead of 1 and 3, I put 3 and 1, I should still get the same result. That's property-based testing. Now, what happens is this. The cool thing about property-based testing, that you're probably like, okay, that sounds like specific inputs again. That sounds like example-based testing. And you're right until I drop this on you, okay? With property-based testing, we're not providing inputs at all. We're not passing in literal values. We're relying on a framework to provide a range of values. So the framework is streaming in values from a range, like from negative 1,000 to positive 1,000, or whatever you specify. So when you do property-based testing, you let the framework pass in the parameters, and it's going to pass in. It's going to execute the same test over and over again with different values, negative values, positive values, really large values, zeros, like edge cases. It's going to do all that for you. And so these tests don't execute in 10 milliseconds or 20 milliseconds. They're not like unit tests. These tests, when you execute them, these property-based tests, they may take 300 milliseconds. And depending on how you configure these tests, based on the range of values that you want to test for, they can take 4 seconds, 5 seconds. They can take 10 minutes based on how you configure it. But the beautiful thing about property-based testing is you're letting the framework manage the edge cases for you. And so that's the beautiful thing is you can still, I think it complements your unit tests, in which you leverage your property-based tests to catch the edge cases, right, or the special cases. And so that's something that application developers can also adopt or take in to their arsenal of tools so far.
That's awesome. It's kind of funny or sad. I was actually last week at a conference talking to a developer of a popular test tool. He's like, yeah, I'm starting to explore functional testing with automation. I'm like, no one does that. I've never heard of anyone saying anything about functional testing. And bam, the next interview I have is actually you talking about functional testing. So I'm so glad I had you on the show, because it's something I've heard about, but I didn't think anyone was really exploring. But it sounds like there's a lot of benefits to functional testing, and benefits that may benefit automation or testers to make your code quality even better.
Yeah, I think what we're learning, and again, I have extreme views, right? I get really excited about things, but I think we're starting to learn, for people that are actually in touch with the industry and the ecosystem of the industry versus company XYZ.
Yep.
We're starting to learn that, maybe we are treating object-oriented principles or object-oriented design as a sledgehammer. Maybe we shouldn't always leverage the principles of continuously mutating states as a way to build reliable software that delivers consistent results. Maybe building software that is based on modifying the state of an object, maybe that can get us in trouble. Maybe functions are a really good thing, because maybe functions really are deterministic. Maybe functions, if they don't modify anything, they don't have any side effects. And if there's no side effects, then maybe that provides a higher probability of higher quality. If functional programming doesn't have any side effects, then maybe we can expect the same result over and over again, versus imperative programming or object-oriented programming, where our programs thrive off of side effects. We're always changing the properties of an object. So I look at functional programming as the next generation of programming languages that it's going to still take a while for mainstream to adopt, but I look at it as a beautiful thing. Just as, C was a beautiful thing potentially to assembly code. C++ was a beautiful thing to C, right? Generation to next generation to next generation. C#, people thought that was the next generation of C++. And I think that within .NET, F# is the next generation for C#, just as Scala or Clojure potentially is the next generation of programming in Java. And I think that, thousands of years ago, when I don't know, tribes would attempt to build shields, it was probably an art, like maybe in certain parts of the world, they just use sticks to create a vest to protect them from spears. And maybe like in the times of Rome, they experimented with bronze and other type of metals, right? But it was still an art. And then like in this millennium, we've taken what's been art and we really made it a science. We use carbon fibers and it's no longer a mystery. It's no longer experimentation, even though we can continue building on it. We know exactly what ingredients to use to get the desired result. And I think that this is where it may be another 100 years off or 1,000 years off, but I think that sooner or later, I think that software development can really mature to being more of a science based on the progression of what has been proven to work and what procedures have been proven to work. And I'm really excited. And again, if I didn't make a decision to investigate other ways of building software, I would have never ever discovered the way that the tools that I can leverage to help me deliver a higher quality code. And I'm so thankful for it.
Awesome. Okay, Scott, before we go, is there one piece of actionable advice you can give us to improve our software craftsmanship skills, and let us know the best way to find or contact you?
This might sound really selfish, but I also think it's good advice. All right. and this is kind of my motto. The more I learn, the more I practice what I've learned, the more I demonstrate what I've learned, the more I'm worth. All right. And so even though I love building software, I also love increasing my worth. I love making more and more money based on what I've learned and what I've demonstrated I've learned to deliver software more effectively compared to the rest of my competition. I'm not sure if John Samez would appreciate this, what I'm going to say, but he's advocated. John Samez is like a software developer coach.
Yep.
In regards to careers, and he's advocated separating yourself from the herd. Removing the herd mentality and differentiating yourself, right? And so with that said, based on the question that you've asked, I would encourage and I would challenge developers to chase the money. And by chasing the money, demonstrate how much more effective you are to the rest of your competition. In order to do that, you have to open yourself up to other ideas, and you have to experiment, right? Do not experiment on company time. Deliver on company time. Experiment in the morning, experiment in the evening, experiment and present your experiments at user groups and refine your practice. Software development is a practice. It's not a job. It's a practice. Refine it. Practice makes perfect. And increase your worth, so that you're making $50,000, $100,000 more than the rest of your competition. And I feel like that's having your cake and eating it too. You build more on how to deliver more effective code, and you're making more money as a result of it. Like, that's the best of both worlds. And so that would be, I think, what works for me, that I think other people should strongly consider. You can find me on my blog that I try to update like every other week. It's bizmonger.wordpress.com. I'm on Twitter, but I really don't know what I'm doing on Twitter. So all I do is pretty much I paste web links that I find are really interesting in regards to software development, and I just put that on Twitter. I don't really express my ideas on Twitter. I just share really good links.
Cool.
So you can message me on Twitter. And if you're able to find my email address, which I'm not going to give out, but if you're able to find my email address, and it shouldn't be too hard to find, go ahead and reach out to me, because I really do enjoy talking to passionate developers, because believe it or not, I don't really have that opportunity to engage with people that really love building software, and I love learning from other people. So that's it.
Thank you, Scott, for your software craftsmanship awesomeness. For links to everything of value that we talked about in this episode, head on over to testtalks.com/82. And while you're there, make sure to click on the Sign Up Now link underneath the exclusive sponsor section to learn all about Sauce Labs' awesome products and services. If this episode has helped you in any way, why not share it with a friend or coworker, and together we can spread automation awesomeness to the masses. I'm Joe, and my mission is to help you succeed with automation awesomeness. So that's it for this episode of Test Talks. As always, test everything and keep the good. Cheers.
Thanks for listening to the Test Talks podcast. Head on over to www.testtalks.com for full show notes, amazing blog articles, and other automation awesomeness.